Hey y'all, good morning and welcome to today's asynchronous video. In this one, we're going to be learning how to use 4 different dots to create 2 similar triangles. And again, in our live lesson section, we went over this example before. So if you already feel like you got it, go ahead, continue on to the practice problems. If you feel like you may need one more example, stick around and I'm going to show you how we can find and prove if 2 triangles are similar. So the first thing I'm going to do is draw my 2 triangles. As you can see, I already have 4 points picked out. 2 are my x and y intercept, and 2 are just random points I saw and decided to go with. So the first thing I'm going to do is draw lines as straight as I can to connect both of my orange dots. And then I'm going to draw some lines to connect both of my blue dots. Cool. So again, things to note about similar triangles is if they are drawn in the same direction, meaning for both of these I chose to go right first and then up, they should take on the same appearance. So let's say I choose to draw these over here on the side. They are both going to give me roughly the exact same shape, just one is a bigger copy than the other. Again, this is kind of our property of similar triangles, is that they should be the same shape, but different scale factors of one another. And so like I mentioned before, the criteria for similar triangles are they have the same interior angles, and their lengths are ratios of one another. So in order to prove that second point, ratios, we need to find the change in y over the change in x for both of my triangles. So I'm going to go ahead and start off with this blue one right here. Again, it starts at my 0 point and then it moves over 2 spaces. So that's going to be my change in x is equal to 2. So over here in my fraction, 2 is going into my denominator. Then I'm going to look at the change in y. So in this case, my y goes 1, 2, 3, 4 spaces up. So my change of y is 4 spaces. So that gives me the fraction 4 halves, or simplify that down to just 2. So now, in order to prove that this orange triangle is similar to the blue triangle we have just drawn, I want to make sure that when I take the change in y divided by the change in x, I should be getting 2 out as my final result. Let's go ahead and start counting. 3, 4, 5, 6, 7, 8, counting 9 spots to the right. So that'd be a change in x is a positive 9. Again, going from negative 3 to positive 6. So over here, I'm just going to write 9 in my denominator. And then counting up. So I know I start at negative 10. So from here, back up to my x-axis, that's a change of 10. And then from this point up to where I need to jump off is 8. So I got 8 as this first length here before the x-axis, and 8 or 10 as the length here underneath the x-axis. 8 plus 10 gives me a total of 18. So this tells me my change in y for my orange triangle is equivalent to 18. Just so we can keep with our notation, change in x is going down here. And so now at this point, I want you to think, can we show whether or not this graph and these 2 triangles are similar? And again, the way that we're going to show that, dividing out those 2 terms gives me 2, showing that yes, this orange triangle and this blue triangle are similar. They have similar interior angles as one criteria for showing this. and their sides are scales of one another, meaning that there is some number that I can multiply 4 and 2 by that will give me 9 and 18. We're not going to worry about that part right now. All I want y'all to do for today is show these two sides are similar by calculating the change of y over the change in x.